All right. Well, this is Monday, the first week of e-learning. This is Algebra 2 regular. You should be watching this as your second video. First video you should watch it would have been the overview of everything that we're kind of doing, a little bit about grading, a little bit about like the layout of the week, that kind of stuff. So now we're jumping right in with the first lesson. These two videos will be short for you this week because they're basically review. We're trying this one via recording via YouTube because we've tried on the Chromebook and a couple other methods, and we're just trying to figure out what is the best way to do this. So bear with me if this doesn't come out perfect, but here we go. So we're talking this week about the review of square root functions and cube root functions. Before we left, we did square root functions, and so today we're just going to kind of review that. What are all the key characteristics? What are all the shifts? How can we tell what shifts are what? And then we will jump right into cube roots in the second video. Remember, this video is to cover Monday and Tuesday, and then the second one will be for Wednesday, Thursday. So here we go. All right, remember when we talked about square root functions? Square root functions. The place we start when talking about them is always with the parent function. Okay? The parent function we said, parent, the mommy-daddy function, is f of x equals square root of x. And we said if we were to draw a coordinate plane, that is going to look directly starting at 0, 0, going up and to the right. Remember, here in regular, we're not looking for exact points right now. We talked about what the exact points would be, but we're just looking for a general layout of what does this graph look like and its key characteristics. Okay? So its vertex point, the starting point is at 0, 0. It's going up and to the right. Okay? Then we talked about the key shifts. Okay? We said if I've got f of x equals, and then underneath here I've got square root of x, we said anything that happens underneath this, whether it be something that's adding to the x, subtracting from the x, multiplying, a negative, something like that, anything under there would make changes to the x coordinates. Okay? While anything out here, whether it be in front or behind, would be a change to the y coordinates. Change to the y coordinates. Okay? So when we're talking about changing the x coordinates, that means it's going to shift from left to right in some way, shape, or form. It might slide to the left, slide to the right. It might flip over, okay, and kind of mirror itself over the y-axis. It might stretch or shrink along the x-axis, but we're talking about changing the x's. We're talking about outside of the radical, not underneath the square root. We're talking about changes up and down. It might slide it up, slide it down, stretch it up, shrink it down, or flip it over the x-axis and do some sort of mirror there, but we're talking about changes to the y's. Okay? So let's do an example just to kind of review. Let's say I've got f of x equals 3 square root of negative x plus 2, and then outside of the radical we've got a plus 5. Okay? So the first thing we said we're always going to do is label our shifts. Okay? So I've got a shift out front, this multiplying by 3. I've got a shift underneath the radical, that negative. I've got a shift underneath the radical, that plus 2. And I've got a shift outside of the radical, this plus 5. Okay? So we said first, this one at the back is going to be up 5. It's going to be a shift or a slide up 5. Remember, outside of the radical, things occur just exactly the way we see them. Plus 5 would slide up 5. The 3 outside of the radical, when we're multiplying by 3, you know, if the y coordinate was at 1, 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So it's stretching it and making those numbers bigger. So this is a vertical stretch. Then underneath the radical, the other two, Okay, we said these ones are kind of opposites of what we see here. So normally when we're talking about sliding left and right, when I see a +2, I would think that would be moving 2 in the positive direction, but underneath the radical it's backwards. Okay, so this would actually slide it left. Slide left 2. Hopefully this is familiar. And then when I've got a negative, remember, is a flip. Okay? So underneath the radical, we're talking about changing it left and right, so it'd be flipping it over the x-axis, or over the y-axis. Flip over y-axis. Now, let's talk about what this looks like. Okay, remember I said, for the purposes of what we're doing, we're going to draw basically the parent and we're going to shift it. Okay, so the parent starts here and goes up and to the right, just like it did over here. It's the exact same thing, going up and to the right. Okay, we said that we want to do these shifts in a specific order. We want to do any slides first. So I'm going to deal with my slides first. I'm going to slide this up 5 and left 2. If I go up 5, that's up 1, 2, 3, 4, 5, and left 2. So nothing changes except this original vertex point is going to go up 5 and over 2. Our graph is still going up and to the right so far, right? Still going up and to the right. Then I'm going to do my stretches or shrinks. In this case, the only stretch and shrink I have is a vertical stretch. So this one that was kind of like this is now going to get taller. We're stretching up. Now, again, we're not looking for exact points right now. We're looking for a general idea of what the graph is going to look like. So it's going to stretch it up, okay? And then we're flipping over the y-axis. Well, where is the y-axis? Right here. So this is being reflected or flipped over the y-axis. Flipping over the y-axis. So instead of it being here, it's going to be here. So instead of the y or the x-coordinate being at -2, now the x-coordinate is over here at +2. And instead of going up and to the right, when I mirror this or flip it over, it's now going to go up and to the left. So it's generally going to look like this. Now, is that exact? Is that perfect? No. But we're looking for a general idea of what is this square root function going to look like. Now, key characteristics. We want vertex, we want domain, we want range, and we want end behavior. Okay? Vertex, domain, range, and end behavior. Vertex is the starting point on the graph. Our vertex in this case ended up at +2, +5. 2, 5. Okay? Our domain, okay, remember domain is the x's that are possible in this graph. Well, this is starting here and going this way forever. So we always go lowest to highest, least to greatest. So the least x is over here at -infinity. Okay? And then it's going this way, further and further and further, but right here it stops. And what is that x-coordinate? It's 2, so it's stopping at 2. Now, remember, when we are including 2 in our graph, we want to put a bracket because it is included. For range, we always go lowest to highest. The lowest this will ever be is right here at 5. The highest, it's going up. Even though it's mainly going to the left, it is still going up. Okay, so it's going from 5 is the lowest, all the way up towards +infinity. Okay? Now, end behavior, we've always talked about going in both directions as x goes to infinity and as x goes to -infinity. But now, remember, when in a square root function, it's only going in one direction. So I only need to show one direction. So, as x approaches, well, which direction is x going? X is going towards -infinity. So as x goes towards -infinity, what is y doing? Okay? As the x's get closer and closer to -infinity, as the x's go more and more in the negative direction, what are the y's doing? They are going up, slowly, but they are going up towards +infinity. So the y's are going towards +infinity. Okay? This should be review for you. This is what we did right before break. So if you already have your notes, you can get that out. Okay? If you don't, I would advise you to write this stuff down. Okay? Changes to the x happen underneath the radical. Changes to the y's happen outside of the radical, etc. Okay? One other thing to note that would be good for us to write down, I didn't write it down right now, but it would be helpful, is the order in which we do our shifts. Okay? We're always going to do slides first. Okay? Then we'll do stretches and shrinks. And then lastly, we will do flips. Okay, so we need to identify what our shifts are, do them in that order, okay, and then find our key characteristics. Okay, on Classroom, you've got some example problems that you're going to be doing with this, just as a little bit of practice, not a ton of them. Okay, you'll notice that I believe the worksheet that you have is in 2 parts. It's one assignment, but we've broken it down into 2 parts, so make sure you read carefully exactly which problems you're supposed to be doing today. Don't forget, today and tomorrow, Monday and Tuesday, we will have our Google Meet where we will be discussing what are your questions that you have, what are your problems, what are things that we need to go over. So if you've watched this or you've looked back at your notes and you've looked at your assignment and you feel like you have no idea what's going on, it would be a good idea to log on to that Google Meet around, I believe we said 1 o'clock. You'll double check, make sure you got the time right, but around 1 o'clock, and we will answer any questions that you have. Remember, this one with square root graphs is for Monday and Tuesday. So please do not log in on Wednesday and ask questions about Monday and Tuesday's assignment. Okay, make sure you get this done Monday and Tuesday. Now, if you want to work ahead, you want to do both assignments on Monday and Tuesday, fine. But Monday and Tuesday we will answer questions about the first video. Wednesday and Thursday we'll answer questions about the second video. All right, that's all for now though. We are identifying the shifts, okay, putting them on the graph and defining our key characteristics of vertex, domain, range, and behavior. Okay, thank you.